All right, in this video, we're going to introduce how to solve absolute value inequalities. So we'll start with absolute value inequalities that involve less than and less than or equal to symbols. So absolute value inequalities are similar to absolute value equations. So for something like the absolute value of x is less than 2, what we're looking for is not the values on the number line that are exactly 2 spaces away from 0. We want all the numbers or values on the number line that are less than 2 spaces away from 0. And so in that case, our graph, our number line, all the values that are shaded make this original absolute value inequality true. So anything that is within 2 units or less than 2 units, I should say, from 0 is part of our solution. So -1, the absolute value of that is less than 2, so we want to include it in our answer. So what happens is the absolute value of x less than 2 means that x is between the -2 and +2. So when you see the less than or equal to's with absolute values, again, make sure you have your absolute value bars alone, nothing else going outside around them. It means just you can have the x's sandwiched between the opposite of this number and this number itself. So example 2, part A, solve and graph each. We have the absolute value of 2x minus 2 is less than 5. And so what that means is that 2x minus 2 is going to be in between -5 and +5, which means we can break this up as a compound inequality. So this would be something to the effect of -5 less than 2x minus 2 less than 5. So we can solve each one individually just like we did compound inequalities. So for this one, I always like to have my variables on the left side. And again, we talked about that in the inequalities, equations and inequalities tutorial. So we're going to add 2 to both sides. In each of these, we'll get 2x is greater than -3. Here we're going to get 2x is less than 7. And so what we have is x is greater than -3/2 and x is less than 7/2. So that's going to put all the values for the solution to this problem inside this little area of the number line, greater than -3/2, less than 7/2. So any number in here will make this original inequality true. Now, that being said, there is another way that we can solve inequalities, and it's going to be something that I like to use a lot because it allows you to solve many different types of inequalities, not just absolute value inequalities, but other kinds that we'll be looking at in this course as well. So I'm going to give you an alternative method to solving this example. And the nice thing about inequalities is once you know how to solve the equations, it's very easy to solve inequalities. In fact, you don't have to worry about flipping negatives, dividing both sides by a negative and flipping your inequality sign. You don't have to worry about anything like that, special cases for certain types of inequalities. So if you treat the absolute value inequality like an equation, and then you can use test values in your original inequality. So if we solve the absolute value equation, we get our -3/2 and our +7/2. Now, on our number line, that's going to create 3 different regions. We're going to have less than -3/2, between -3/2 and 7/2, and greater than 7/2. Notice we're using open circles because it's less than, not less than or equal to. So what we want to do is we want to test out values that are in each of these intervals, these regions here. And we only need to test out one. So using Desmos, here we have our absolute value of 2x minus 2. So if I want to start with a number that is less than -3/2, let's say -2. Well, I could plug it in for here, or I could just find where -2 is, and I get 6. Now, we're saying that the absolute value of 2 times -2 and then -2 is less than 5. Well, when I plug in -2, I get a 6 here. So is 6 less than 5? No, it's not. So I don't want to shade this part of the number line. A number between -3/2 and 7/2, like let's say 0, let's say if our y-coordinate when x is 0 comes out to be less than 5. So our y-coordinate when x is 0 is actually right here, it's 2. So is 2 less than 5? Yes, it is. So we want to include values between negative 3 halves and 7 halves, as we saw in the answer to this problem originally. Now for numbers bigger than 7 halves, let's say, I don't know, let's go with 4. When we get plug in a 4, we get 6. Is 6 less than 5? No, it's not. So we don't want to include values that are greater than 7 halves. We only want to include the ones in between. Also notice if we graph this, the absolute value of 2x minus 2 less than 5, where is the graph in red? Below the graph in purple. And it's below the graph in purple between negative 1.5 or negative 3 halves and 3.5 or 7 halves. So again, where is this graph? Below this graph. This is below this graph between negative 3 halves and positive 7 halves. All right, part B, absolute value of x minus 9 less than or equal to 2.9. We can separate this into two inequalities and add 9 to both sides. We get x is greater than 6.1 or x is less than 11.9. So shade in between, and they do get closed circles because of the less than or equal to part. All right, part C, we have absolute value of x plus 2 less than or equal to negative 1. And this one is actually, again, no solution because absolute value of x plus 2 is guaranteed to always be non-negative. This should be non-negative here. So if we take a look at the graph of absolute value of x plus 2 and negative 1, notice they don't intersect. And also, more so, where is the graph of the absolute value? Where's the graph in red? At or below the graph in purple. It's not at or below it anywhere, so there is no solution. So this one has no solution. Again, absolute value of x plus 2 is always guaranteed to always be non-negative. So it should be a non-negative there. So this one again is no solution. As an alternative approach, if we treat it like an equation and solve it, we get negative 3 and negative 1. But as we can tell when we plug them in, we don't get the left and right sides to be equal, and no test values work, so there is no solution as well. So, all right, that about does it for this video. Thanks for watching.